If your memories are the only direction you can look, why does the future feel open and the past closed? Does time actually flow, or do we move through a structure that's already there? And if flow is just a feeling, what in physics makes that feeling so reliable? Let's start with a pocket test of reality. Two friends sync their watches, hug goodbye, and split. One boards a plane, the other stays on the ground. They reunite, compare wrists, and find their seconds disagree. If time were one river running past all of us at the same speed, why did two travelers measure different currents? Einstein's answer turns the map sideways. Time is a dimension woven into space, spacetime, so asking for a single universal now is like asking for a single global flat map of Earth, useful locally, misleading globally. Simultaneity is the idea of a shared now, and relativity says it's relative, like slicing a loaf at an angle. Different observers cut different slices. Proper time is the time your own body clock measures. Think of it as the length of your path through spacetime, not the ticks of some cosmic wall clock. Geometry, not a master metronome, sets durations. On this map, it's tempting to adopt the block universe view, past, present, and future laid out like a complete tapestry, while each of us traces a glowing thread, a world line, through it. Yet our lives are not tapestries we calmly examine. They feel like stories we're still writing. So where does the arrow in that story come from? Enter entropy, the most misunderstood celebrity in physics. Entropy is not disorder so much as how many ways the microscopic pieces can arrange while the big picture looks the same. A tidy room has few microarrangements. A messy room has many. So, left alone, systems usually drift from rare to common states, from low entropy to high, because there are just more ways to be messy. Coarse-graining is the way we blur details. It's like calling a whole crowd cheering without tracking each person's heartbeat. The thermodynamic arrow emerges because, for reasons we still debate, the early universe started in an extraordinarily low-entropy condition, the past hypothesis. Imagine the cosmos as a deck of cards beginning perfectly ordered. Shuffling happens relentlessly, and far more decks look shuffled than pristine. The bottom line, microscopic laws are reversible, but our macroscopic lives inherit an arrow from an exceptional beginning and the way we ignore microscopic details. Quantum mechanics complicates and clarifies this. Schrödinger's equation, the rule that makes quantum states evolve, is time-symmetric. It runs forward or backward equally well in principle. So why does a measurement feel like a one-way street? Because of decoherence, when quantum information leaks into the environment like a drop of ink dispersing in the ocean. In practice, the universe records our outcomes everywhere, air molecules, photons, your retinas, making the unmeasuring fantastically improbable. Clocks, then, are just systems undergoing reliable change, a cesium atom's vibration, your heart's lube-dub, Earth's spin. Time is what change measures. Now narrow the frame to the human mind. The brain stitches a brief living window, the specious present, like a rolling 3-second theater where sensations and predictions overlap. Memory is a storehouse of durable records, physical footprints of low-entropy past states. Our feeling of flow is the sensation of continuously updating an internal model of the world. No cosmic conveyor belt is needed for the rush of now, only a brain writing and reading records, always leaning forward. And yet, at the frontier, something more unsettling emerges, quantum gravity's problem of time. When we try to fuse quantum mechanics with general relativity, certain approaches lead to the Wheeler-DeWitt equation, h psi equals 0. Think of it like a perfectly held chord with no drumbeat, no external time parameter ticking anywhere in the deepest description. How does motion reappear from a timeless score? Relational ideas answer. Time is not a master clock but a correlation between parts. In the Page-Woodhouse mechanism, one subsystem plays the drummer for the other. You don't ask, what time is it absolutely? You ask, when my clock shows this, what does your system do? The flow is a story about relationships, not an independent river. The thermal time hypothesis goes further. Given a state's statistical structure, you can define a flow that acts like time, like the way a city's traffic patterns define rush hour without needing a universal siren. Some think the very atoms of causality might be discrete. Causal set theory imagines spacetime as a growing partial order, dots of events with before and after links, like a cosmic family tree. If this is right, the smooth geometry we love is the large-scale blur of a granular, ordered rain of events, and the arrow might be as fundamental as the direction of those links. Gravity itself seems to sculpt arrows. Near black holes, gravitational time dilation stretches rates like taffy, your seconds and mine drift apart in extreme curvature. Holographic ideas hint that the growth of interior volume, or computational complexity may track an arrow, Complexity here means how many steps it takes to build, or unscramble, a quantum state, like measuring how hard it is to restore a Rubik's Cube from chaos. Is this a deep clock or a brilliant metaphor? We don't know, but the rhyme between growth and complexity and our felt arrow is hard to ignore. Reality invites stress tests. Loschmidt's paradox asks, if the microscopic laws don't prefer a direction, why doesn't entropy decrease as often as it increases? The answer circles back, overwhelmingly typical behavior plus special initial conditions. Rare is not forbidden, but the dice are loaded by the cosmic opening move. Closed time like curves, loops in spacetime where you could, in principle, meet your younger self, appear in the math, but nature may police them. Quantum effects and Hawking's chronology protection conjecture suggest that paradoxes destabilize the very conditions that would allow them. And in the lab, indefinite causal order experiments show that, at the quantum scale, even before and after can blur, operations can be arranged so that A influences B and B influences A without a single clean order. The macro arrow survives, but the micro foundation is stranger than any clock shop. So we hold an open tension, a timeless fundamental equation, an emergent statistical arrow, and a mind that experiences flow. How do these layers lock together without contradiction? Maybe like music, a score that is static on the page, a performance that moves in time, and a listener whose emotions give the movement meaning. On the human scale, what does this make you? If spacetime is a tapestry, you are a luminous world-line pattern within it, the shape your choices carve. Agency isn't a magic hand outside the tapestry, it's the way local actions select which correlations, and therefore which futures, become real along your path. The arrow of time is not an illusion to dismiss, it's a real statistical gradient of our cosmic neighborhood. Memory, growth, responsibility, grief, joy, they all live inside that gradient. Ethics becomes the stewardship of records. What we do leaves durable traces in a one-way thermodynamic world. We choose which marks we etch into the environment, which stories we make easy or hard to erase. Daily practice? Build better clocks by tracking meaningful change, not just minutes. Reduce friction, entropy production in systems you care about, clearer processes at work, calmer routines at home, designs that waste less, habits that conserve attention. Cultivate memory with care. It's your local time machine, a ledger of low-entropy traces that can guide your next move. We do not merely drift in time. We participate in making it, by entangling with the world, by writing records, by walking the bright edge where a quiet, timeless equation becomes a life with a direction. Synthesis. The future feels open and the past closed because the universe began in a rare, low-entropy state, because quantum information disperses irreversibly into our surroundings, and because our brains, acting as prediction engines, experience the ongoing update as flow. In the deep structure, time may be correlation, not a thing. In our lives, the arrow is an emergent gradient that gives meaning room to grow. Contemplative takeaway. Tonight, try this thought experiment, pretend that nothing flows. Treat your next hour as a landscape you walk through by making records. Notice every trace you leave, a note, a photo, a promise, a breath. Ask, if my past is the archive of traces, which one am I choosing to add right now? The next great question, if the arrow of time is a pattern that emerges from change and correlation, what is the true nature of a decision, an act that seems to select one future over another? Or, put more personally, if time is an illusion, what does that say about the memories we hold most dear?